Right, so we will be going to illustrate right now how does the depth first search work in here. Now the step one, for example, we will be going to search the K right now. So the step one, you have to search from this one here at the top level, which will be the A. So your DFS right now is A. And you have to make sure to also put that inside the stack. So your stack right now, you were able to have push A. So you don't have to put the top location already since this is just a representation for the searching. I don't need to ask or I'm not asking for the locations of the top element already. That is in our data structures and algorithm already happened last semester. So this is just a simulation for the searching na. For the step one, we're done with that. So since the depth first, we are starting that in the left side. So what will be the left three or left sub three? So that will be our step two. So for step two, sorry, my pen is not really working. Now, right now, since in your data, what is the adjacent of A. So you can definitely identify that right there. The adjacent is um B and C. However, choose D. So the adjacent, you can put it right there. Adjacent of A is B and C. Then specify, choose the left node, choose B. So that's how you will do it. So after choosing B, you have to insert B in your stack and push B right now. And then again, your DFS, make sure to put right there, since this is the visited element. So your visited element here is the A and B. Now we're done with that. So in your step three right now, you have to check, are there any adjacent of B? Since we cannot insert C right now because in your B that is not the dead end. Now what you have to do, what is the adjacent of B? So the adjacent of B is D and E. So however, what will be the element that you will be going to choose in this one? So according to the child nodes of that B, the left child is D. So therefore, you can definitely choose B right now. Then in your stack, what will happen since you were able to choose D? So what will happen in that case? You just have to push D right now. And then your DFS will become A, B, and D. That's how it works. So you have to continue up until the very depth or the what we call this one the dead end of that particular tree. So according to the tree that you have for the step four, in that particular example, are there any adjacent of D? What is the last top or the top element? Is it D? So adjacent of D right now is according to that three is J and H. So if we will be going to assess that one, what is the left sub three that is choosing letter G? That is the element G. Right now, what will happen? You have to update your stack then again, and you put G at the top element, and then push G, and then your DFS will be updated into A, B, D, and G. So this signifies that DFS is a visited element actually. Now in your step 4, let me just put this or transfer this in another location so that I could continue here. I'm sorry. So transfer that there. So your step 4 right now, that is adjacent that your the thing that you are doing right there is the gene. So what will happen in your step 5? So you have to assess, I'm so sorry. Um this, let me just delete this first because supposed to use okay, so for inconvenience. Now, what will happen in your step 5? So according to the this one earlier, your last element is G. So you have to get the adjacent of G. So adjacent of G is 9. So what will happen? You have to pop the element. So your element earlier is A, B, D, and G. A, B, D, and G. So since you were not, there's no child node of G anymore, since that is none, so you have to remove this G in your, so pop G already. So since you were able to pop the G in your step 6, just make sure that you have to follow this because this is a refined step that I want you to deal in your examination, a step-by-step process. So make sure to follow this then. Now, after you pop the G, you could somewhat the DFS retain that is A, B, D, and G. So you will not remove something because this is the visited elements actually. So you will not touch anything in that one. Now, after you were able to identify, since you were able to backtrack, your location right, the top location right now is D. So you have to make sure to track adjacent of D. Are there any adjacent of D? Yes, that is J and H. So according to that one, what is the element that you were not able to visit? So since you already visited the G, so make you have to choose H right now. So sorry. Choose H. So therefore, what will happen in your stack? A, B, D, and H. So therefore, you have to push H in your stack right now, and then your DFS will become A, B, D, G, and H. So you're able to visit 5 elements. So by the way, for the since we are searching the specific item, I forgot to give you as well that in every step you have to compare that in our key as the key element. So you have to check here as well. Does A is it equals to K? So you just have to follow through that. No. So keep on searching. So does B is it equals to K? No. Something like that. And D, what will be the element at the top of your at the top of your stack? That will be your thing that you have to compare here. So G right now, is it equals to K? No, the same. And here then, make sure to follow this implementation para uniform the answer. And checking G is it equals to K. Mo lang question mark. Still no. Then afterwards, since you were able to insert the H right now, I don't know, not G and this one here. It is a D right now. D, since that is a top element. What will be the element in your top? You have to put here as well. So D is it equals to K? No. You just have to put it right there. Now H, is it equals to K? No, still. Since we're now at step 6, what will happen? Step 7, you have to check the adjacent of H. Since that is the element of your top element. Adjacent of H, there's none. Since here then, that is a dead end. So what you have to do, you have to remove H already. Now, DFS will not be going to change anything in your DFS that must be retained in that thing. A, B, D, G, H, and then compare your naman again because your top element right now is D. So although that you were able to check that earlier, you have to still keep on tracking everything, okay? So that step by step procedure. D is it equals to H? No. Afterwards, for the step 8, you have to check the adjacent of D. Since adjacent of D, that is G and H. However, you were able to visit all of them, so backtrack. So since you were able to visit the G and H, you were able to exhaust that one, so you have to backtrack. What does it mean? You have to remove D in your stack already. So right now, will become A and B, then up. I'm so sorry then. You were not able to put here earlier, pop H. So make sure to really keep on tracking everything that you need to do. I will be going to give you the possibilities or the correct format in your test paper as well, so that you will have the format structures for this. Anyway, so PAP D, and then your DFS right now is still A, B, D, G, and H. Then is it B or is it equals to D? And no. Afterwards, for the step 9, adjacent of B. So you have to check, are there any adjacent of B? So for checking in your here, what is the adjacent of B? That is D and E. So therefore, D and E. Now, you have to check in your DFS above. D is already visited in a DFS. So therefore, you definitely put that right here. Choose the unvisited node, which is the E. So you have to choose E, and then what will happen since you do have A and B in your stack right now, you have to insert E since that is the element that you wanted to insert. So push E, and then your DFS will become A, B, D, G, H, E. And your, you have to compare, does E, is it equals to the key element, which is K. And I'm so sorry. We're actually having a mess here. It's not H. Absent-minded, sir. So that is K. No, that is K. Mhm. And then the same here. Oh my goodness. Okay. Now afterwards, you have to compare right now. This E is equals to K. No, that's not equal. Now, since it's still not, you will be going to exhaust everything. So what is your last element right there? You have the second, which you have to check the adjacency of E. Are there any adjacent of E? So you have to go back above. So what is the adjacent of E? That is I and J. Since there are I and J, so check as well. Were you able to push or earlier in your stack I and J? So it's not visited yet. So you can definitely choose I because that is the left node. Choose I. Then afterwards, since you were able to choose the I particularly, what will happen in your stack? You have to update A, B, E, so sorry, and I. Die. Thank you. Push I. And then your DFS will be A, B, D, G, H, E, then I. Yeah, that's correct. And I is that equals to king. So since that's not yet the element, so what will happen? Have to break through the same thing. Now, step 11. So adjacent of I. So what is adjacent of I? Let's try to check. There's no adjacent of I. That is a dead end. So what you can do? Backtrack. So the same thing with the thing that we were able to do earlier for the H, none, um, none, then put here backtrack. None or just backtrack. And the same with non backtrack. Okay. That we need to make sure everything is the same some as well because that is really critical in terms of our implementation. We must have a uniform answer. Don't want to deal that you will definitely just put another answer right there. No, no, no. That's a no, no. So there's none. So you have to backtrack. Afterwards, since you were able, you will be going to backtrack. What will happen in your stack? So you have to remove I. So pop I, then your DFS must be you still have to retain the same element right there. A, B, D, then G, then H, E, and I. And I thank you, Chris. So it's somewhat lag, but it happened to my iPad. So then what is the last element? E, is it equals to K? No. So what will happen in the step 12? You have to check the adjacent of E. Then what is adjacent of E? Going there is I and J. So I and J. So checking the DFS that you do have, you're able to have already the I in your DFS. So that means to say, you have to choose J already. Then, after choosing J, you must do like this. Push J in your stock. A, B, E, and J. And then push J. Then your DFS, what will happen to your DFS? It will become A, B, then D, then G, then H, E, I, and J. So, thus J is Z equals to K. No, the same thing. So what will happen? You will check as well here. Step 13. Adjacent of J. Checking in your figure 3, there's none. So you have to put here none. And then, since none, what you have to do, remove the J and do backtrack. So put backtrack. And what will happen? Draw the stock as well, A, B, E. Then pop J. Since you were able to pop J, the same thing implementation, your DFS, retain those element A, B, D, G, H, E, I, and J. And what is the last element or the top element is E. Is it E as equals to K? No, the same thing. You put that, keep on trucking. So proceed with the step 14. For step 14, what is the last element? Adjacent of the last element, that is E. So adjacent of E, going into your graph, I mean 3, that is I and J. So put here I and J. So what about I and J that is already visited in our DFS? So since that was visited already, so what you have to do, you cannot choose. What you will deal here, backtrack. The same as what you have did in the previous thing here for D, G, G and H. So since you cannot do or visit I and J anymore, since that's done, you have to just put simply backtrack. Afterwards, by backtracking that, you remove E. So back E, and your DFS must be retained in that form. A, B, D, G, H, E, I, and J. And what is the last element? That is B. Does B, is it equals to K? No, the same thing. Afterwards, I'm so sorry then. It automatically exit. So after you were able to have here in your step 14, since that is B is not equals to K, that is no, it's what being mentioned earlier. So what you need to do, you have to proceed with the next thing. That is now. So this next step will be, I'm so sorry, let me complete this. Step 15. So adjacent of the top element, that is B. So going back in your 3, is there any other what is the adjacent of B, that is D and E? So D and E. So try to figure out in your DFS here, D and E is already there. So D and E is already there, so you have to just backtrack since that was visited. as the rules interpreted that you can only visit once. So therefore, you have to be in your stock. So your DFS will be retained ABD GHEIJ, and your last element is A. Is it equals to K? No, no. And step 16. What is the adjacent or the top element? That is A. So what is it element, adjacent to A? Checking in this figure here in the tree, that is B and C. So therefore, put that right there, B and C. Checking in your DFS, does B is already there? Yeah, that's already visited. What about C? No. Therefore, we can choose. I don't know. I'm sorry. Choose C. Absent-minded. So what will happen since you will choose a C, insert C in your stack, so that is push C. And then your DFS must be updated since you were able to visit C right now. A, B, D, G, H, E, I, J, and C. So comparing that one, does a C, is it equal to K? No, that is not. So since we were not able to have or visit, found a K yet, continue the process. What is the adjacent of C? Are there any adjacent of C? Going back into your tree, that there is adjacent which is F and K. So there are F and K. So therefore, F is the left subtree. You have to visit first. K F. So it will become A C F push F. So since you're able to push F already, your DFS must be updated into A, B, D, G, H, E, I, J, C, and F. And then check, does F, is it equals to K? No. Therefore, you keep on dealing the next steps, step 18, and then adjacent of F. Are there any adjacent to F? Checking in your tree right here. So there's none. That's the dead end. So what will happen in this case right now, since that is not, there's none. So you have to backtrack. What will happen right now, since you will backtrack, you will remove F in your stock. Back F, and your DFS must be the same thing. A, B, D, G, H, E, I, J, C, F. And then compare C, is it equals to K? No. So since you were able to remove these F already, go with it. Step 19. Are there any adjacent to C right now? Of C. So checking there for the adjacent of C, yes, there is F and K. So going back here, F and K. So since F and K, so F is already in our DFS. So K, you have to choose that one. Choose K, and then your stack will become A, C, K, and then push K. And what will happen, I'm so sorry, in your DFS right now, it will become A, B, D, G, H, E, I, J, C, F, K. So compare, does K, is it equals to K? Yes, we found the element. So that is how you will definitely deal with this algorithm right now. This is the process that you will need to deal. You must put the step each step you put the this one you have to define. I will begin to make sure to put here. So the thing that you will begin to do, define the adjacent, and then put put a specific element of choice. Specific element of choice. And then afterwards, you have to track the DFS. After tracking the DFS, you also have to compare top element, top element into the key element, into the key element that you do have. Afterwards, if found, so you have to return yes only. So that's how you will deal with the depth first search. I hope that that is somewhat clear to everybody. The step one up until the step 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So in the final case here, K is found at step 19. You must put right here. For example, step 19. And wala na siya. That's how you will deal with that. So I hope that is somewhat clear to everybody, and I'll begin to proceed with another searching algorithm in the next video. Thank you.